Hello, science students. Today we're going to talk about wave interference. So far we've talked a little bit about waves in general and the different parts of a wave, like the amplitude and the wavelength and the frequency and the crest and the trough. And we've talked a little bit about the EM spectrum, or the electromagnetic spectrum, different light waves there. We've talked a little bit about sound waves. Now we're going to talk about something called wave interference. So our goal today is to be able to identify examples of constructive and destructive interference of waves. So first, what is wave interference? Wave interference occurs when waves traveling through the same medium collide. So basically there's a little rule there. So if I have sound waves running through light waves are kind of moving through space, sound waves are moving through the air, they're not moving through the same thing. I don't need air for the light waves to move, and therefore they're not going to interfere with the other. Now, there are circumstances where light can run into other light and cause some interference. There are circumstances where sound can run into other sound and cause some interference. So we're going to focus on that today. So you can also kind of think of it as it has to be the same type of wave. Okay, let's take a look at our first example. So let's say we have two kids, they're in a pool, and they push a wave at each other. Okay, not too atypical. With summer coming up, this may happen to you even. So if kid number one, we'll call this kid number one, and kid number two, they push a wave, and I'm going to use red just to make it easier to see the wave. I'm not saying the water's red, it's just the color I'm using. So if kid number one pushes this wave, and it's going to the right, kid number two pushes this wave, and it's moving to the left, those two waves are going to move closer, closer, closer until they hit each other. And when they hit each other, what happens is, since they're on the same side of the water, you can kind of think of it that they're both above the water, they're going to constructively interfere and increase the amplitude. So when we add them together, we're going to get one tall wave that is 2 times as high. When they're all done, so we can kind of show an after photo. So if here's our water, wave, we'll call this wave number 1 and wave number 2. This is number 1 plus number 2 because they've added together. Afterward, wave number 1, it's going to continue going to the right. Okay, and wave number 2 is going to continue going to the left. They just move through each other. Okay, so kid 1 and kid 2 are going to get hit by each other's waves. There's just going to be a nice big wave in the middle. This is actually something you can go try in like a cup or a small bowl. You can actually see the ripples kind of interfere with each other. If you shake a bowl or a cup of water, you can see this. So that's constructive interference, is when the amplitude of two colliding waves increases. So they're kind of on the same side of the wave, they're going to increase their amplitude. Let's look at the last example. So this time, let's look at destructive interference. So if you haven't figured it out already, so constructive, so something that's constructive is going to build, they're going to get bigger. Destructive means this is when the amplitude of two colliding waves will decrease. So if I wanted to make a wave that would perfectly, going to the left, that would perfectly cancel out this wave, what do you think that would look like? So take a moment, think about it, and then we'll give it a try. Okay, so now if I wanted to double the size of the wave, I would make sort of the reflection of that wave. What I want to do is cancel it out. So that means I need this part right here, better be a part of my wave on the opposite side, and then this would line up. If you could see that I could lift this up and drop it over here, it needs a bit that would cancel it out over here, kind of like this. Maybe a little bit wider. Okay, and that one's going to the left. So now you can kind of see as they move, once we get to the middle, I'll try to replicate my orange wave. It would look like this. And the red wave would look something like this. So now, these would cancel out, and we would get no wave at all for a brief moment. After they pass through each other, once again, so we can draw kind of our after image one more time. Once they've passed through each other, we're going to get both of those waves back. So I'll get my red wave back and the orange wave back as well, and they will continue on their way. So they interfere and then they continue. Hopefully in this week's lab activities, you get to play with the slinky, and you may actually notice some of these things happening. You may actually notice them in a few of the other activities as well, but the slinky is kind of where you can get the best example of this. I may even post some videos on how to see that later on. Okay, so key things, there's interference of waves. They can run into each other and change each other's shape a little bit. They will continue on through each other. And there's constructive interference that increases the amplitude and destructive interference that decreases the amplitude. And in this particular case, you can see that this would be called completely destructive, where when they hit, they would cancel out, and what we would really get in the middle is just a flat line of no wave at all for a brief moment before our waves continued on to our after image here. Okay, thank you all for watching, and good luck with all the activities this week.